Hello guys, welcome back to the new video we have here. This is first time in a few weeks, we just come back into it. So we have this specimen paper from the 2024 series. The first like 6 questions are really easy, so I'm just going to skip them. So we're going to get onto this question first. So firstly we're just going to draw AC because this is important finding the area. We know that AB is 8 because it's a rhombus, because all the sides are equal. Then you just find the area of this triangle here, ABC, and then multiply it by 2, because this is the other triangle here, it's the exact same, and you just do this, and this is the area. Alright, this next one is incredibly easy. I don't know why they even put it here. It's just, you just draw the cubic and it tells you all the points. So it's really easy. I don't know why they even put it here. But yeah, let's just move on. Alright, this next question is actually pretty weird. It's just a circle theorem question, proving that AC is a diameter. So firstly, we know that 10x is 180 because we just add all the x's together and opposite angles in a cyclic quadrilateral add to 180. Then we can find x, and we know that these two pairs of angles these two pairs of angles, they both equal 5x, which both add to 90, which means that these two angles here are both 90. And because angles in a semicircle equals 90, we can prove that this is a diameter, because we can prove otherwise that this equals 90 without the circle theorem. But now we know it's 90, we can tell that this is a diameter, because otherwise this wouldn't equal 90. Right, next, function stuff. So f of a third, we just substitute g of a third, you will just leave it like this, because we just substitute the 1/3 in. Then we can make them equal to each other, because it says in the question. Then we just solve. So we square it to get this, you rearrange a bit, so add p 127, so take away 4/9, and put the p on top of the fraction, and just from simple fraction stuff we can find p here as 15. Alright, next we got this circle question, very easy circle question. You can tell that C is 3, 2, because it tells you the y coordinate here, it tells you these 2 points, which are on the same y-axis, so if you just find the midpoint, then that's going to give you the midpoint here. Then we know the radius is 3 because it's going from C to here, and then from that we can just write the equation out as it's asking. Alright, this is just some cosine rule stuff, I'm not going to do it, it's just you find x by using this and then cosine rule. But it's just simple, it's so easy. Alright, these next 2 questions are also really easy. This is just normal GCSE rearranging, this is just normal GCSE rationalising. So again, I'm just going to skip them. Alright, this is an actual further maths question, so we're actually going to go over it this time. So this is just a normal question. We're going to find the derivative first, as always with these kinds of questions. Then we're going to substitute the point that it gives us, -4, to find the gradient of the line, or of the tangent. Then, because it's a normal, we're going to do the negative reciprocal. then we're going to write it as an equation like this. We're going to substitute the -4 back into this equation to find the y coordinate of this A point here. Then we're going to now we can substitute all these points back into this equation. So the 4 from here and the -4 from here, we can substitute. So we can find C, and then we just put it in an equation like this, and then multiply it by 3, and it gives us this. Right, so this is the next part. You're doing a simultaneous equation with the normal and the curve. So we're just going to write these 2 equations out, set them equal to each other because they both equal y, and multiply by 3, rearrange, quadratic formula. And this -4 solution we already saw from earlier, it told us in the question, so this is the other solution that is looking for this -2/3 here. Alright, again, skipping these 2 questions, sorry for all the skips this time, but a lot of these questions are either really easy or really long. which in this case, these questions are just really long. They're just testing your sense of time in this part of the exam, even though it's not an exam you really have to rush that much because it gives you an hour and 45. Alright, this is just some filler stuff. You just multiply by -3/2 to get x, just x by itself, because these fractions simplify, and then you just do this fraction here and get the answer. Alright, this is an actual question, it's a more differentiation. We're going to derive this function here, we're going to get this, we're going to solve this function using, but we're going to realise that this b squared minus 4ac is less than 0, which means that there's going to be no solutions because you can't root a negative. And that means that the gradient is always going to be above 0 because the quadratic, which is this quadratic is always above the x-axis because there's no solutions, which means that the gradient will also be above 0 because this represents the gradient, this thing here. Alright. Next, we have this last question here, this trig question. As you can see, this has been a pretty easy paper so far. And for this question, we're just going to write it out as it is. Then for this next question, we're going to do what we already did in the last question, converting the cos squared into sine squared. Then we're going to just rearrange the constants here and this number. Then we're going to multiply by -1. We're going to substitute u in just to make it easier to look at. Instead of all the signs, we just have this now. Next, we just solve for u. And now we resubstitute the u into sine x. And we find solutions. Alright, thanks for watching. That's this specimen paper here. I kind of rushed through a lot of the questions because it was quite an easy paper. But just hope you can re-solidify your knowledge on some of these things, like the differentiation and the trig. Alright, thanks for watching. Goodbye, guys.